welcome to Pharma-Code. My name is Raphael, and in today's video we will be developing an ideal body weight calculator. A bit of the theory there are a number of reasons why we need to identify the ideal body weight an individual should have for various medical reasons, because you don't want to be overweight or underweight or obese due to so many other medical reasons. And so in today's video I will be walking us through how to use Python to develop an ideal body weight calculator, and I hope you enjoy it. And also, as a disclaimer, I don't work with Python every day. I might have mentioned this earlier. I work with C# every day, so for all the Python gurus out there, permits me pardon some of my errors, and let's get to it. So I have Python shell opened here, the IDLE shell, so I'm going to be creating a new file. So first we need to walk through our logic. We are creating a very simple application. We want to collect user inputs, so we would receive inputs from the user. We would process these inputs and make calculations, and then we will display results, which is going to be the ideal body weight. And here, that is it. So I think that is our workflow: receive input, process input, display results. So that's what we'll be working with. And then we would need to define what those inputs are. We would need to define what formulas to use to run our calculations. We would also need to define what results we want to display to the user. So I'm going to take us real quick to, I found a material online on medicinenet.com where basically it explains a common formula used to calculate the ideal body weight of males and of female, and also a couple of reference formulas from different individuals on how to calculate ideal body weight. So we'll be starting with using this common formula for male and for female. So from this formula we realize that we're going to need a couple of inputs. We're going to need the gender of the individual, we're going to need the current weight of the individual, we're going to need the height as well of the individual in meters. Okay, so let's get right to it. So in Python, when we want to display an information to a user, what we do is we use the print method, and so we want to tell the user the name of this calculator. So it's going to be ideal body weight calculator, and this is by Pharma-Code. We also want to print out the instructions, so we're going to say something like input the weight in kilograms, the height, that is in meters. We also need the gender. Select the gender, and what else do we need? Yeah, the weight, the height, the gender. I think that is all. Okay, yeah, because we're going to be using a couple of formulas, right? So we also need to tell what formula the individual would like to use. So select the gender and formula to calculate ideal body weight. That looks good. So now that we have title and our instructions in place, so here we're just basically display title and instructions. So now we need to receive inputs. So we're going to declare a variable called weight, which should collect the input from the user. So we're going to say input to weight in kilograms, right? And then same thing for height, so we could just copy and paste height in meters, right? Okay, so for gender, we want the user to be able to input the gender without errors. So we're going to help them a little. We're going to do something like gender to call to input, because we want to do a lot of text. So I'm going to use this. So we're going to say select the gender, and we're going to say they should input 1 if it is for male and 2 if it's for female. So input the number that corresponds to the gender. Okay, so that should do it. And then also the same thing for the formula as well. So they're going to have to input 1 for male and 2 for female. So we're going to do something similar for the formula. So select the formula. So there are quite a number of them. So this is a common formula. So we're going to say 1 for common formula. And then this is Hamwi's formula. Okay. Devine's formula. Robinson's formulas in, and Miller's formula. So which is the number. So, formula. Okay, all of this looks good. Then we're going to need to cast our inputs, because all of these are going to come in as strings and we definitely want them to be numbers. So we're going to cast them to, so we're going to cast these two to floats, and we need to cast these two to ints because they're going to be 1, 2, 3s anyway. So so a couple of copying and pasting to make this go faster. And yeah, so gender is going to be ints, that's good. Formula also can be int, because we're going to only expecting 1 and 2, 1, 2, 3, so that's good. Okay, that looks good. So depending on our formula type, right, we want to be able to, we need a way to be able to identify whether we're going to be using the common formula or the other formulas, right? For this purpose, I'm going to prefer to use the switch, so we can switch between cases of if they imputed 1 as common formula, 2 as Hamwi's formula, right? So I'm going to use a switch here. So For the case of 1, we want to use the common formula. I'm going to define a method called common formula, which should take in arguments of our inputs, which is going to be the weight, the height, and I believe the gender. Yeah. So we need to define this method. So to define this method, yeah, I could go ahead to define this method. The common formula method, which takes in all of these arguments. However, this is going to be problematic because all of this needs to be in a different method for this to be able to work properly. So I'm going to need to move all of this into a main method. So I'm going to define a main method here, and I'm going to put this as a script, so it only runs as a script. So let's call the main method when this is run as a script. And yeah, I think this is good. Okay, so let's define what happens in common formula. For the common formula, this is what we know should happen. So if it's a male, we want the ideal body weight is going to have to be 22 multiplied by the height in meters squared, and if it's a female, it's going to be the height in meters less 10 centimeters before we square it up and multiply by 2. So this looks pretty similar, except for this part of the equation that's different for both of them. So what I'm going to do is I'm going to call this my multiplier, and I'm going to switch it out if it's going to be for male or if it's going to be for female. So I'm going to do something like this. I would say my multiplier should default to 1 or 0. I think 0 makes more sense. Then I'm going to say if yeah, I think so. I'm going to say if the gender is equal to 1. So this means this is a case for male, right? So if the gender is 1, that means we're doing the male calculation. Then our multiplier is going to be the height squared. So this is height raised to the power of 2. Otherwise, we know it's going to be female. So we're going to do this. Otherwise, female, and then our multiplier is going to be the height less. So 10 centimeters to meters is going to be 10 divided by 100. I'm just going to make this simpler. 10 divided by 100 is 0.01. Right, 1, 2, yeah, 0.1. What's Google there for? 10 centimeters to meters. Yeah, so that's 0.1 meters. That's correct. Okay, so we have this, and then we do this by the power of 2. So that's what's happening here. Height in meters squared, or height in meters less 0.1, and square this. Okay, then once we have this, then we can say our ideal body weight, which I shorten as IBW, is going to be 22 multiplied by our multiplier. Okay, and then we have our ideal body weight. We probably need to round this up, so we're going to do that to 1 decimal place. Yeah, and that looks good. Then we need to display this result to the user. So we're going to print out this information. We're going to say ideal body weight is equal to, so before we concatenate strings this way, we have to use the string method here to cast this into string, otherwise we have errors. And then kilograms, but this looks a little bit messy, so I'm going to use a string formatter. I believe it's F, and then we can do something like this. So we can put in this variable directly into the string formatter, and so it knows to replace IBW with the value that's here. Okay, so now we have our ideal body weight. But there's something about this material. It says the individual is obese once the percentage is 30, once it's 30% or more than the ideal body weight. So we need to be able to calculate how much deviation the current weight is from the ideal body weight, and that is, I believe, in simple mathematics. So we're going to do something like this. We're going to call it percentage difference, and that is going to be, we're going to take the current weight less the ideal body weight divided by the ideal body weight, and we're going to multiply this by 100. So just so that our brackets are correct, we'll lessen this first before dividing by this and then multiplying by 100. So what this is going to do this, okay, yes, now I have this, then we're going to say we also want to print out this result. So I'm going to be using the formatter this time. So we're going to say the percentage difference is, we can pass in this variable here in curly brackets, this percentage, and then we can say, okay, now we have this. So we want to display if, so once this percentage is greater than 30, we're going to display if the weight is obese or not. And we can say, I'm going to call this indication. Yeah, I'm going to call this indication. So we're going to say if, okay, percentage difference, let's just copy this so that I know typing errors is greater than 30. Indication is equal to obese, else let's just call this normal. Okay, so I think I like to give a default, it should be a default value for this. Okay, and then we can print our results here saying print indication Okay, so this looks good, I believe. So we defined a method called common formula. We are sending these arguments, weight, height, gender, and then we are defining a multiplier based on the gender. So if it's male, we do this directly. If it's female, we less 0.1 before we square it up, raise to the power of 2. We calculate our ideal body weight, round it up to 1, and then we calculate the difference, and then we display the results. So I can already foresee something that's going to happen, because we're going to need to display the results on each of these formulas, and it's going to look like repetition if we have to do this percentage calculation all over again in multiple places. So I'm going to pull all of this into a separate method. I'm gonna call all of. I'm gonna call that method display results. Well, we're going to understand what parameters to pass in. So I'm going to define display results here and then put all of this in. So we're going to need the weight and the ideal body weight. Yeah, I think that's pretty much everything we need. Okay, so we're going to need the weight and the ideal body weight. So this display results method is going to receive the weights and the ideal body weight, and based on those two parameters, it's going to calculate the percentage difference, and it's going to display the results that we need to see. So we've done a whole lot of work. Let's just see if all of this runs well. I'm going to save this in my dedicated folder and the body weight folder. Okay, let's call this ideal body weight. Yeah, calculator. Okay, and let's run this. Yeah, so Pharma-Code ideal body weight calculator, input the weight. So let's just use 70. The height, let's say 1.6 meters. Select the gender, 1 for male, 2 for female. So input the number that corresponds to gender. That's gonna be, let's use male. And then the formula, of course, now we only define the common formula for now. So let's do 1 and then hit enter. Great, so we have our ideal body weight as 56 kilograms, and then the percentage difference is going to be 24.333925. So we're going to need to approximate this as well, and then the indication is normal because this is less than 30%. So it all looks good. That's great. So let's just do one thing here. We need to round this up to, I think 1 decimal place is okay. Yeah. So that looks good. So what we have to do now is define the other formulas and run them. Yeah, so we're going to have to do for case 2. Case 2 basically means if case 2 for formula is going to be the Hamwi's formula. So let's call that I'm going to take in the same arguments as well, width, height and gender. So we're going to need to define this. So what's going on with Hamwi's formula? So Hamwi's formula says if it's a male, we're going to have to do this 48 kilograms plus this kilogram per inch over 5, and then for female is this for 2.2. So what are the difference? Definitely we know we're going to be doing every inch over 5, so it means first off this is different for both, and this is also different for both, but it also has a similar pattern. So definitely we know we need different formulas for male and for female. Okay, so we're going to do this. We're going to define all the things that are separate. So this is like the addition side of things, so the addition factor and then the multiplier. So I'm just going to call it additive. No, let's just call it addition. Sometimes it's a bit funny when you struggle with variable names. So we're going to go with the default of 0, and then our multiplier is also going to be 0. Then we're going to define for male. So if gender equals 1, then we know we're dealing with male. And then the addition factor is going to be 48.0. So I'm going to probably do this 0.0. The multiplier I think should also be 0.0. Okay, so multiplier is 2.7. Okay, and then the else condition here is obviously going to be the female version, because if it's not 1, it's going to be 2. 45.5. So our addition factor and then our multiplier is 2.2. Okay, that looks all great. Then we need to define that our ideal body weight is going to be wherever the addition factor is for male or female. Then we need to add that with whatever the multiplier is. So for every inch above 5 feet. So we're going to need to convert, I believe we need to convert height in meters to feet and inches, and then once we make the subtraction, so we're going to convert our height in meters to feet and inch, and once we do that, then we make this the difference, and then we multiply it with our multiplier effect. So let's just do Google meters to feet. So 1 meter is 3.28084 foot. Okay, so I think we need to make this conversion. So we're gonna do something like this. Height in so height in feet is whatever height is multiplied by okay, so now we have our height in feet. Okay, great. So now that we have our height in feet, so all we need to do is to okay, so now that we have all our calculations in order, we just need to run our display results method. So I'm going to put this here, and then we're passing in the weights and then the antibody weight that we just made the calculation, and then that should display the results. So let's run this and let's see how it goes. Hopefully no errors, fingers crossed. Okay, so we're going to be using similar parameters: 71 kilograms, 1.6 meters, male, and we're going to pass in 2 as a formula for Hamwi's formula. Okay, great. So we see here our ideal body weight is 48.62, the difference is 43.8, and then indication is obese. So using Hamwi's formula, that same individual with these same parameters is obese, but using common formula, the individual is not obese. So we see here I need to approximate this to 1 decimal place, so I'm just going to need to update the formula to reflect that. Other than that, that sounds good. Okay, so I need to do this. Round ideal body weight to 1 decimal place. Okay, so that looks good. So we could just replicate this method all through. Let's do a little bit of cleanup here. So we basically can just replicate this method all through for the other formulas, and we have our ideal body weight calculator that has the ability to calculate the ideal body weight using 5 different reference material formulas. Okay. So this is 50.0, 45.5 for this. .5 the same. The distillation is 2.3 and 2.3. So this has similar. So the multiplier for this is the same, 2.3. Okay, so 2.3 is the multiplier for this, so this does not require separate multipliers. We also need to convert the heights in meters to feet. Okay. Okay, so let's run this. Devine's formula is 3. Okay, that looks good. So let's duplicate Robinson's formula as well. For case 4. Robinson's formula. Okay, so for male, this is Robinson's formula here. The addition factor is 52 and 49, male and female. And then the multiplier factor is 1.9 and 1.7. Okay, same thing, we convert feet to meters to feet, subtract, multiply, round up, display results. Robinson's formula. Let's see how this runs. So I'm going to be using 71.6. This I'm going to be using female. And then Robinson's formula is number 4. Okay, all runs fine. No errors, so I believe that's good. And the last one is Miller's formula. The same thing. basically just copying and pasting the block of code we had done earlier, the method we rewrote earlier, and then just modifying it to each formula's calculation. Weight, height, gender. Okay, so the addition factor is 56.2, 53.1. 56.2 to 3.1, and the multiplier is 1.4 and 1.36. Okay. Okay, that looks good. Now that we have this here, okay. So I believe this converts, this multiplies, and adds, this rounds up, and this displays the result. So let's run that and let's see how it goes. So 71.6, female, Miller's formula, that's 5. And then here we have our calculation, which is 53.4, 31%. So that looks good. So now that we've written out all the methods for each of our formulas, let's just look around and see a couple of things that we can clean up or write better. Okay, so first and first I realized is we did a lot of conversion of height to meter. We duplicated this line of code in so many places. So I believe we can put that out into a separate method. We're going to call that let's call that convert snake case for Python. Yeah, convert to so we're going to convert this to floats, and then it's going to take the value, and then it's going to run basically this. So we're going to return value multiplied by this factor. So that should convert our meters to feet. So we're going to need to replace this. So what this means is that if there is any error, basically this would help us to, first off, like I used to say, it would help us be able to unit test our converter. It would also help us to, if for instance there is an error with our conversion, we only need to make that change in this method once and for all, and every other place is being used, the correct or the updated calculation is going to reflect in every other place. So that's one of the reasons why we have to refactor this, right? So I'm going to move this, replace it with this, replace it with our method, convert to fit method, convert to fit method. Yeah, I think that's good. Also, there's a general rule that says never trust user inputs. So we're gonna need to make sure that the user doesn't input things that are non-numeric here in this part of the inputs. So for weight and height, we're expecting numeric inputs, and then we want to stop the program if they input something that is invalid. So I'm going to call this method convert to floats. Yeah, I think it's nicer if I probably pull this up here. Yeah, some days like this I wish I was using an ID for this, but I just think it's probably easier and nicer to just do everything on an ID. For the Python developers out there, what ID do you use for your Python development? I believe Visual Studio Code is good enough, but just let me know what you think. Okay, so now we define our convert to float method, and then we want to try to make this conversion. So we're going to try to return the float value, otherwise catch the exception, and then print out issues value only, and then we want to gracefully stop this application, gracefully exit it. So I'm gonna need to import sys and then do sys.exit. Yes, sys.exit should gracefully exit it. So in case if they input the right value, it's going to make the right conversion. However, if they do the wrong thing, input the wrong value, it's going to gracefully exit it. It's going to display this message, please input the right values only, and then exit the application. So we're going to use this instead of our direct convert to floats, instead of our direct floats methods there. Okay, so let's test this out and let's see if it works fine. So they are meant to input numerals here, but let's say they input ABC. Oh, I see. So this is probably not going to display the error right now. Okay. Yeah, so it's gonna. So it broke right here. Please input numeric value only. And then it exited the application because obviously we can't calculate anything with ABCs, right? Okay, so that works. Let's call this numeric values. Okay. Then for our select inputs as well, we're going to do something similar, but we're going to call this convert to ints. Because technically they are doing two different things. So yeah, the error message can be the same, that's not bad. These are convert to ints. However, there's a problem. What if the user decides to input 3, which is outside the range of what we have here, which is just 1 and 2 for male and female? So we need to be able to catch that error and stop the user at their tracks. So let's try to do that now. So we're going to do something like validate inputs, and here we just want to check if gender is in range of, so we're only expecting 1 and 2. So if it's in the range of 1 and 2, so in this case we need to check if it is not in the range, because that's when we want to print the error. and then we also want to exit the application. Okay, so we do if gender not in range of 1 and 2. I'm going to print. What should the error be? Invalid input. Please select we're asking them to input the number that corresponds to the gender, so we're going to say invalid input, or input does not correspond to the gender. Okay, so their input does not correspond with any that. We're basically doing this for the formula as well. We're expecting a range of 1 to 5, and so we say invalid input does not correspond with any formula, and then we exit, and then here and then if all of that is good, then we will move on to match the formula, and then we work it out. Okay, so all of this looks good. Let's test out our validators to be sure they run fine. Okay, so let's do 71.6. So we're going to put in 3 here, which does not correspond to any gender, and then put in 6 here. Okay, yeah, invalid input does not correspond with any gender, so we're going to need to run this again and test out the formula part. 6 invalid input does not correspond with any formula. Okay, so now we basically tried to make our application kind of user input friendly. So it shouldn't break as long as it selects the right input, and we've kind of safeguarded most of it. So this pretty much looks good. So let me know if you have any questions, and let me know if there are other ways you could have done this or written this better. But I enjoyed building this ID body weight calculator, and see you in the next video. Au d'abord, bye, au revoir.